Okay, so for example 4, we're going to take a look at the square root of 32. So the square root of 32, 32 divided by x, and I'm going to get my list of factors. 1 times 32, 2 times 16, and 4 times 8. Those are my choices. So I have 1 times 32, 2 times 16, and 4 times 8. Now, I kind of mentioned this on example 2. When I'm looking through my list, since I want to find the biggest perfect square, I'm going to always start on the right column. I'm going to work my way down the right column, and then I'm going to work my way back up the left column, because I want the biggest number that I see. Is 32 a perfect square? No. Is 16? Yes. See, if you work the other way, you could be tempted to grab 4 and 8. And I'm going to show you that in a second. So I'm going to take 16 and 2. Once again, always write the perfect square first. Take the square root of 16. Square root of 16 is 4. Bring the second piece down. Now, let's say you didn't catch that, and let's say you used the square root of 4 times the square root of 8. You would take the square root of 4, which is 2, bring the second piece down. But if you checked here, this number 8 doesn't. This number 8 also has a perfect square factor, because 8 is 4 times 2, or 2 times 4. So then you'd have to break this down again. So I'd write the perfect square and then the non-perfect square. So I'd be breaking up the square root of 8 into the square root of 4 and the square root of 2. Everything's getting multiplied together here. So I would take the square root of that first piece, which is 2, bring the second piece down. These 2's up front multiply together, and you get the same exact answer as I got here. So you can see how much more work it takes if you don't grab the biggest perfect square. So that's why you always want to take that biggest perfect square.